we're going to remove the official BIOS from this Dreamcast and replace it with a custom hybrid BIOS. This will require hot air, loads of flux and spheroids formed from a carbon iron alloy. This will unlock a few features not found in normal machines. Then again, I'm anything but normal myself. Cake. Let's do this thing. Right now.
Mark fixes stuff.
This video is sponsored by PCBWay. You can get an instant quote on a variety of services, or browse a library of talented makers' designs, add them to your cart, and have them delivered directly to your door. The Dreamcast is one of my favourite consoles of all time. It had so much untapped potential, but it sank Sega's hardware division for good. Sad times, but let's cheer up Sad Panda with a new BIOS. First, we need to tear down the console. There are 4 screws, with the 4th being underneath the modem. The modem is removed by pushing the tab and pulling it out. The 4 screws come out as you'd imagine. Note that the external screws are all black. With the screws removed, let's turn the console upright. I like to remove the top of the case with the lid open because I can see better. Next, we need to remove the power supply. The switch connector has a lock which needs to be pushed in at the top. There are 2 screws and a retaining clip holding the board. The 2 screws holding the PSU in place are gold coloured and the shorter of the 2 types. Next, we release the pressure on the retaining clip. And being careful where you slip your fingers, pull the power board free of the case and connecting pins. Don't touch the underside of the PSU. If it's been on recently, you might be in for a shock. Sorry. Put the insulating sheet safe with the PSU and don't lose it. Now let's remove the GD-ROM drive. It's held in with 3 screws. These are also gold screws and the same type as are used to hold in the power supply. These screws are self-tapping into the metal shielding, which can make it a bit stiff. With the screws gone, pull off your unit with a firm hand, making sure not to touch the lens. The controller port board is next. It has 4 screws. These screws are also gold in colour, but these 4 screws are longer than any of the others, so pay attention. The longest ones can only fit into the front holes. Now for the data and fan cables. The data cable is the flat type, just pull it out evenly. Removing the fan cable is easier with the board free. It gives us more room. So the controller board is out. There are mods for this, but that's for another video. Holding the board and shielding in are a further 8 screws. 2 gold screws. And 6 black screws. Don't miss this one down by the fan. These slip out nice and easily. Time for some speedy tool action. These are the same as the outer case screws, so can just be put into the pot. I'll take out the front panel early so you can see more easily, but this is the first thing you replace when rebuilding it or it won't go back. Grabbing the shielding and fan, we lift the top shield out of the case and the main board comes with it. On the underside of the board are some heat generating components, and these need to be mated to the thermal pads on the lower shield. Make sure that these haven't dropped off or gone missing. There are two larger thermal pads on the top of the board, and these can cause the top shield to stick to the PCB. You'll need to gently pry them apart with a rigid tool until you can slip your fingers into the crack. Here, one of the pads has remained on the shield and one has stayed on the chip. Just make sure that both are present and not lost. The BIOS chip in the Dreamcast is IC501. This is the replacement kindly sent by Coaster2K from eBay. We won't need the resistors because we'll be fully replacing the original chip and not piggybacking onto the original. The chip is programmed with Japanese Cake developer BIOS 1.031. There is a later version which we will update to, but be warned that 1.032 is not very compatible with GDEMU boards. We're going to take the chip off of the board. To do that, we'll be using hot air, heat-resistant polyamide tape, and a flattened KitKat wrapper. Because who doesn't like a four-fingered treat? First, we put our foil over the chip as a heat shield for the surrounding components. Next, we can fix it in place with the high-temperature tape. The colour of this tape always reminds me of the plastic wrapping on Lucasade bottles in the late 80s. It was basically a get well tonic made of pure sugar, which probably gave my generation diabetes. Next, some lovely flux. This is RF800 No Clean SMD flux, my favourite and reasonable to buy. I have the hot air temperature at 360 degrees, which translates to about 320 degrees on the board. After a preheat, we slip in the tip of my fine tweezers under the chip as a gentle lever. A bit more heat and the legs lift easily. You can see now they're all separated. Let's do the other side now. We use the same method, but this time using the tweezers to lift the chip as soon as the solder melts. The pads will need to be cleaned off next. We need the pads cleaned so that the new chip can sit properly. Introducing solder wick, my friend and my enemy. Lots more flux for this. The trick here is to get your wick really hot and keep it moving until it's totally saturated. It all seems really easy until it goes wrong. Your wick is not always your best friend. As an example, if you were to overheat the wick, you can easily pull off a pad, like here. On the scope we can see that heat has delaminated the pad. I know that pin 25 isn't connected, so not a problem, but let's put it back anyway. Here's the pad, sat on my wick. And I'm not joking when I say that these can be small. I've got the pad back and now we need to fix it on. I tend to use a gel-type cyanoacrylate adhesive. The merest dab with the tip of a pin is enough here, and it doesn't set immediately. This gives us a chance to get our teeny tiny pad back into position and flatten before we let it dry. If this pad was connected, we could use a solder bridge or Kynar wire to further repair the board. After an hour it seems set enough to continue, but I'm not sure. So I've asked the gummy crew to come and take a look. They said alcohol makes everything better, so we're going to wash down with IPA. Let's put the new chip onto the board. With the chip roughly aligned, we tack one of the pins to hold it in place. Then, making sure that all the pins are on the pads, we tack a second pin. I'll be hand soldering the legs of the new BIOS. I prefer this method over paste because I can see what's happening. I also tend to reflow the joints a second time on chips like this. Well, it's not beautiful, but it is installed. Now we need to do two connections with this supplied wire. First, we need to go from pin 1 to pin 23. Roughly measuring the length needed, we cut it to size. The other wire goes from pin 44 of the BIOS chip to pin 14 of the GD-ROM connector. This wire is too thin for my stripper, so I have to use a knife. The supplied wire is perfect and not too thick. More flux on pin 23 and we'll attach the wire to the existing solder. Then we route the wire around the chip and do the same for pin 1. Although I used a little extra solder on the iron for this one. That looks okay and the connections are solid. Next we need to identify pin B14 for its connection to pin 44. We'll start at B14 because it's easier this way around. B14 is one pin to the right of the centre of the connector. I've soldered onto the pad here because it's easier than getting to the pin underneath the plastic housing. It's a good solid connection and we can route around to pin 44 of the BIOS now. I forgot to strip this end of the wire though, so we'll have to chance using the side cutters. Having lucked out, I then add some more flux. And tack the wire onto pin 44. And that is the technical part of the BIOS install done. These wires are all really rigid, so I won't need any tape over the top of them. Making sure that our thermal pads are all in place for the shielding. Okay, let's put this all back together. Don't forget to put the controller port cover in first. Put the rear ports into their holes before laying the board down. As you put the top shell on, guide the fan into place. And make sure not to trap the fan wire. We'll put the 6 black screws in first to hold the top shield in place. Next, the GD-ROM slots into position, being mindful of the connector. There's an alignment pin on the plastic case here. The drive is fixed with 3 of the shorter gold screws. The controller port board is next. I'll be making a video on the fuse and battery mods very soon. Gently but firmly slip your cable into the slot until it won't go any deeper. Then massage the ports into place. Pop the fan plug in, and then using the 4 longest gold screws we fix the controller board into the console. 2 more of the golden screws into the PSU side of the shield. Then we make sure the switch cable is correctly routed. At this point, you can clean the PSU pins if you haven't already. Also notice that the PSU board will need to physically slot into the rear of the case. These pinholes and this slot. Line them up and push them down. Then we make sure that the clip is over the top of the power board. Pop in the 2 gold screws that hold the PSU. And the power switch plug clips into place. At last, it's time for the top shell. Again, I find having the lid open makes it easier to locate it. Those 4 black screws fix the shell back together. Not forgetting to replace the modem. It's testing time. Sad Panda says yes. With the new BIOS, I very quickly discovered that there's no menu in version 1.031, but the latest version is incompatible with the GDEMU units as I said earlier. There's no drive emulator here, so let's update to 1.032. With the later version, pressing start when you're in the options menu gives us some interesting choices. You can change the boot animation in a variety of ways, or turn it off entirely. I chose black just to be awkward. You can choose to have Music Interactive Live or backup CDs boot directly after reset. There's a handy option to turn off the Sega license screen for faster boot times. You can switch on some 3D options in the main menu. I didn't like these, so I turned them off. So, is it worth doing? Well, if you have a later DC that won't boot backups natively, then yes. If you have a DC that boots backups already or a GDEMU, then probably not. Fun install though. A massive thanks to my Patreon supporters who make these videos possible. Here they are on the screen. And thank you for watching my video. Perhaps you'd like to watch some more. Here, I'll put some on the screen for you. Bye!